Jupiter from a distance of 600 million kilometers from the Earth. At the bottom, you can see the trail of the fall of the asteroid. As you know, Jupiter is the largest in the solar system, and it has 79 satellites. Several space probes visited the planet, which studied it from a flyby trajectory. And the Galileo spacecraft, having entered its orbit, studied it for several years. The most recent was the New Horizons probe. After the flyby of the planet, the probe received additional acceleration and headed for its final target, Pluto. Jupiter has rings. They are not as large and beautiful as Saturn's because they are thinner and weaker. The Great Red Spot is a giant storm that has been raging for over 300 years. Despite the fact that the planet Jupiter is truly huge, it did not have enough mass to become a full-fledged star. The planet's atmosphere is huge. Its chemical composition is 90% hydrogen and 10% helium. Unlike Earth, Jupiter is a gas giant and does not have a clear boundary between the atmosphere and the rest of the planet. If you could go down to the center of the planet, the density and temperature of hydrogen and helium would change. Scientists distinguish layers based on these features. The layers of the atmosphere in descending order from the nucleus are troposphere, stratosphere, thermosphere, and exosphere. Jupiter does not have a solid surface, so scientists determine the lower limit of its atmosphere at a point where the pressure is 1 bar as a certain conditional surface. The temperature of the atmosphere at this point, like that of the Earth, decreases with altitude until it reaches a minimum. The tropopause defines the boundary between the troposphere and the stratosphere, which is about 50 kilometers above the conventional surface of the planet. The stratosphere rises to an altitude of 320 kilometers, and the pressure continues to decrease while the temperature increases. This altitude marks the boundary between the stratosphere and the thermosphere. The temperature of the thermosphere rises to 1,000 Kelvin at an altitude of 1,000 kilometers. Jupiter contains small amounts of compounds such as methane, ammonia, hydrogen sulfide, and water. This mixture of chemical compounds and elements contributes to the formation of colorful clouds that we can observe with telescopes. It is impossible to say unequivocally what color Jupiter is, but it is approximately red-white with stripes. The ammonia clouds that are visible in the planet's atmosphere form a collection of parallel bands. The dark stripes are called belts and alternate with the light ones, which are known as zones. These zones are thought to be composed of ammonia. It is not yet known what causes the dark color of the stripes. The Great Red Spot. You may have noticed that there are various ovals and circles in its atmosphere, the largest of which is the Great Red Spot. These are whirlwinds and storms that rage in a highly unstable atmosphere. The vortex can be cyclonic or anticyclonic. Cyclonic vortices usually have centers in which the pressure is lower than outside. Anticyclonic are those that have centers with higher pressure than those outside the vortex. Jupiter's Great Red Spot, GRS, is an atmospheric storm that has been raging in the southern hemisphere for 400 years. Many believe that Giovanni Cassini first observed it in the late 1600s, but scientists doubt that it formed at that time. The Great Red Spot is an anticyclonic type storm and has maintained its shape for centuries since we have seen it. It is so huge that it can be observed even from earthly telescopes. Scientists have yet to figure out what causes its reddish color. Why Jupiter is not a star. It lacks the mass and heat needed to start fusing hydrogen atoms into helium, so it can't become a star. Scientists have calculated that Jupiter would have to increase its current mass by about 80 times in order to ignite fusion. But nevertheless, the planet releases heat due to gravitational compression. This reduction in volume is ultimately what warms the planet. If you're worried about your weight, consider that Jupiter has a much greater mass than Earth, and its gravity is much stronger. By the way, on the planet Jupiter, the force of gravity is 2,528 times more intense than on Earth. This means that if you weigh 100 kilograms on Earth, then your weight on the gas giant would be 252.8 kilograms. Because its gravity is so intense, it has quite a few moons, as many as 67 moons, and the number can change at any time. Its temperature, given how far it is from the Sun, is much lower than on Earth. The outer edges of Jupiter's atmosphere are much colder than those in the central region. The temperature in the atmosphere is minus 145 degrees Celsius, and intense atmospheric pressure contributes to an increase in temperature as it descends. Having plunged several hundred kilometers deep into the planet, hydrogen becomes its main component. It is hot enough to turn into a liquid because the pressure is high. The temperature at this point is believed to be more than 9,700 degrees Celsius. A layer of dense metallic hydrogen extends up to 78% of the planet's radius. Near the very center of the planet, scientists believe that temperatures could reach 35,500 degrees Celsius. Between the cold clouds and the molten lower parts is an internal atmosphere of hydrogen. In the inner atmosphere, the temperature of hydrogen is such that it has no boundary between the liquid and gas phases. Jupiter and Earth. When Jupiter and Earth are closest to each other, they are separated by 628.74 million kilometers of space. At the farthest point from each other, they are separated by 928.08 million kilometers. In astronomical units, these distances range from 4.2 to 6.2 astronomical units. All planets move in elliptical orbits. When the planet is closer to the Sun, this part of the orbit is called perihelion. When it is further, aphelion. The difference between perihelion and aphelion determines how eccentric the orbit is. Jupiter and Earth have two of the least eccentric orbits in our solar system,